So hello, my name is Paul Hudson, and my talk today, optimistically, is called iOS 12 in 4.5 minutes. There's a very small decimal point there, you can't quite see it. Now, 45 minutes. So the basics first. I want to talk about who am I, just to outline in a minute or so what I do. If you haven't heard of me before, I run a site called Hacking with Swift, where I publish stacks of news and features and tutorials and more about Swift. It's at hackingwithswift.com. My main job is writing books about Swift, or iOS, macOS, tvOS, watchOS, Swift design patterns, ProSwift, and more. I'm a rather busy person. Helpfully, this week it's DC, so they are all half price. You can go to this URL here and get them and save lots of money, which is great. A few months ago, I released a new course called Swift in 60 Seconds. It teaches Swift in 100 one-minute videos or less. It's free online to work through if you want to. I run the Swift Community Awards, where you can vote for people and projects that affect you most. Show your appreciation that way. And in the last 2 months or so, I've been working extraordinarily hard in this countdown to DC project. I had this idea, I know, I'll do a new Swift tutorial every single day for 60 days. I am actually about 10 years older now after 60 days, but I got it done. If afterwards you want to get in touch, I'll be here. But you can tweet me. I am 2straws on Twitter. I am 2straws on GitHub. On Reddit, I'm 2straws. And on Stack Overflow, I am 2straws. So it's pretty easy to remember once you get the first part down. By all means, email me. I am Paul at hackingwithswift.com. Okay, enough about me. Today's plan. So you should know already that DC is a huge event. It is 5 days with 4 simultaneous tracks running from 9 a.m. to 6 p.m. plus labs. This is a big event. And for the benefit of folks watching on video later on, this is actually Wednesday morning. We're less than halfway through DC. There are stacks of things Apple haven't even talked about yet at DC. So I thought, I know. I'm going to say, let's get all the things announced about iOS 12 and Xcode 10 and so forth, shrink it down to one small box and summarize it in 45 minutes before Apple's even talked about it themselves. Now this might sound like a really bad move, a career suicide for a speaker. But wait, there's more, because these slides here about me and the talk and so forth, after they go away, it's going to be all live coding. We know what that means on a stage, don't we? But I thought, why stop there? Let's go the whole hog. Let's do it with the Xcode 10 beta and the Mojave beta and also the iOS 12 beta. So basically, what could possibly go wrong? Well, pretty much everything could go wrong, right? This whole thing could be the biggest car crash you've ever seen, but you were here to witness it. Well done. So, I have been at DC. I've been grilling as many engineers as I can find. Why does it do this? How does it do that? And so forth. I also wrote my own iOS 12 API diffs, so I can dig through and see exactly what's changed and really try things out as fast as possible. And I run this site called what'snewinswift.com, where you just select your current Swift version, select your target Swift version, and it will tell you all the changes with code examples as you go. So at this point, I've got a pretty good example of what's changed and why across Xcode 10 and Swift 4.2 and iOS 12. Now the trick. Can I condense that, summarize all these things down in a clear and useful way you can take away and apply in your own projects? We're going to find out. But first, 3 rules for the rest of this talk. First one, there are a ton of changes in Swift. Some amazing things like conditional conformances, recursive constraints, case iterable, amazing, randomness, and so forth. I am not going to cover any of these things here. We're going to be Swift code. I won't be talking about what's new in Swift. For that, I've got a great website for that. Or find me afterwards, ask me then. Secondly, there's going to be no magic, right? I personally hate it when you go to www.dc and they say, this amazing new feature takes just 2 lines of code and it all just works, and what you can't see is all the stuff in the iceberg below the water, or the boilerplate to make it work. Oh, and by the way, they're not going to hand out their code to you, heaven forbid. So it's sink and swim. I'm not going to do that here. You will literally see me write every line of code required to make this work in your own projects. And finally, I know many people thought iOS 12 would be a landmark, huge release, all new iOS, macOS, super UI framework, dark mode, and more. Apple, they had other plans. It's not a particularly epic release. Now, I could stand here and give you all sorts of snark about how it's an empty wasteland in the release notes, but I'm not going to do that. Instead, I'm going to talk about what actually changed you can really use in your own code. First up, CreateML. This is the new way of working with CoreML, and it's just fantastic. Secondly, the new way of grouping alerts and notifications on the lock screen. Thirdly, the new linguistic tagging framework, natural language. Then there's Siri shortcuts to hook in your app's UI directly into Siri voice commands. Briefly, we'll do password autofill, and also there are some API tweaks. That's it for the slides. It is time for the live coding. So I'm going to exit this, kill Keynote, and try and activate screen mirroring. And you can tell me whether you can read. Come on, screen mirroring, please. First one of the day is over there. It's over there. Brilliant. How do I get it over here? Let's quit that and try again. System preferences. There we go. Displays. Come on. Displays and mirror. Okay. There we go. Yeah. The first of many challenges. If that's as bad as it gets, we're going to be amazing today, all right? So this is it running in super sexy dark mode, which is cool. Can you read that okay in dark mode? I can switch to light mode. Do you want light mode? Light mode? I'm like 25% more pro in dark mode, you know. All right, general, light mode. Whew, baffling bright. Okay. We're going to start with CreateML, right, which is Apple's new toolkit for creating machine learning models. Now, you should know already, last year, CoreML kind of revolutionized the way we do machine learning because it made ML accessible in our pockets. And these tiny, tiny phones can now do machine learning, of course. The actual things behind CoreML aren't magic. They've been researched for a very long time. It's common knowledge how they work. It's not special. But being able to have it in our apps everywhere we go is a dramatic change. What CreateML changes is the ability for anyone to create models very, very easily. As you will see, we're going to create 2 today. So previously, we used, or I used at least, I'm not sure how many of you have done CoreML stuff, Apple's CoreML tools in Python. It kind of worked. It kind of cooled down to, TensorFlow and scikit-learn and similar frameworks below. You had to do some Python. It wasn't ideal because Python, but you got there, right? And it kind of worked. With CreateML, anyone can now noodle around and try things out and get results very quickly and build apps to do machine learning, which is fantastic. So here is Xcode 10. I'm going to go ahead and create a playground. And I'll just do a blank one on my desktop. Is that font size nice and clear? You're at the front. People at the back, is the font size nice and clear? Yes, good. Okay, so it just takes literally 3 lines of code to get started with CreateML for images. The first one's trivial. We're going to import the CreateML UI framework. That's a bit that handles all the UI for doing CreateML. Brilliant. Second line is to create an instance of their ML image classifier builder, the thing that reads through images and figures out what they mean. So it'll be let builder equals ML image classifier builder. Make the window slightly bigger, perhaps. There we go. Open close parens. And finally, builder.show in live view. That's a lot. Go ahead and press run. Have a little think. It'll crash. I'll press run again. It'll crash again. Xcode 10's super stable. They've done a really good job. Come on. There we go. And it'll say here in the output frame, open assistant editor. Thanks for that. I'll do that now. Boom. And you're now seeing the create.ml UI on the right-hand side here. It's telling us it's going to create a model called image classifier, and we're going to drop images to begin training. Now, you can use whatever pictures you like, whatever obviously your app depends on, right? Here, we're going to ask create.ml to train a core ML model that can recognize cats and dogs. Here's some cats, here's some dogs, which one's which? And the first step behind this is training. You've got to give it some data. This is a cat, this is another cat, this is a third cat, and so on. Then this is a dog, this is another dog, and so forth. And this is actually surprisingly easy to do. On my desktop here, I've got this folder called Material, and there's a folder called Training Data. I'll zoom in a little bit so you can see it. Does zooming work? It does work. You'll see Training Data here. Inside that's a folder called Cat, which contains a load of loose JPEGs called like photo144.jpg. These are all from unsplash.com, a Creative Commons license, or public domain, license, collection of photos. So there's a picture of a cat, and another picture of a cat, and another picture of a cat, and so forth. Loads of pictures of cats. They have zero metadata. There's no exif behind these saying it's a cat. There's nothing in the file name saying it's a cat. We only know it's a cat because it's in the cat directory. Same for dogs. It's a dog, 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 and so forth. So there's different pictures in different folders, and the folder names are what create.ml uses to understand what these things are. Now, it doesn't understand, and it will never understand, what a cat is. We're not trying to train it for like a four-legged feline that likes mice kind of thing. We're training it to understand that these pictures equal the text string CAT. That's our job around here. So, we're going to zoom out here again, and I'm going to take this whole training data folder and just drag that folder into where it says drop images to begin training and release. You'll see it flash through pictures really quickly and say it's done. Now it's reporting back to us here that it has model accuracy 100% for training, which is, well, obviously it can 100% its own stuff, but it's saying, great, I recognize cats and dogs pretty well. But can it? How good is the model? And that's where testing comes in. You've seen a lot of pictures of cats and dogs. I've kept aside some different pictures of cats and dogs. Cats and dogs it hasn't seen before. And I'm going to say, okay, here's some different pictures. How well can you recognize these? And Apple recommends, well, generally recommends, 80% training, 20% testing. So, I have a separate folder called testing data. And it's exactly the same. Inside that is cat with some photos, and inside that is dog with some more photos. Again, no exifs, no interesting file names, just pictures of cats and dogs. So I'm going to take this training data folder and drag that where it says drop images to begin testing. You'll have a little think, and it comes back with 100% accuracy on these cat and dog pictures it has never seen before. You can drill down, you can say, you know, how accurate were you? I was 100% confident that's a cat. It tells you for every picture, this is a cat, definitely a cat. Now, of course, it could be lying here. Maybe Apple are doing some hand waving. So we can have a go at this. We can say, okay, let's rename this thing to be, that's training. Let's rename this one to be cat2, and this one to be just cat, and that one to be dog. So I basically switch the folder names around. So I've called the cat folder has pictures of dogs. Inside, there we go, few little doggies, and the dog folder is some cats. Now, let's try it with that testing data. It'll come back with 0%. It got them all wrong, because we've switched it around, we've lied to it. So it's not some magic here, it really has managed to train this model effectively to detect cats and dogs. Now, I haven't given it very many pictures, I ideally give it more than this, but you can see how extremely fast and easy it is. Now, the next step is to say to this thing, okay, click here, save the model somewhere. So I'll choose my documents perhaps, and it'll save there to my documents. And if I just go to that quickly, there we go, what's it called? There we are, image classify ML model on my desktop. You will see that entire model takes up 17 kilobytes of storage, which is nothing, right? It can recognize, with my data, of course, more testing will be good, 100% of cats and dogs in 17 kilobytes. It is remarkable what this thing can do. Now, if you find with your data that these numbers aren't 100% and 100%, which is your goal, maximum training efficiency, maximum validation efficiency. If you find that isn't the case, there are some things you can work around. If I just quit that and start again, I might have to put my beasties back temporarily because I've renamed them slightly. So let's call that cat2, that one cat, and that one dog. That should be now, hopefully. Pictures of dogs. Yeah, great. If you find that your model data isn't sufficient, if you get like less than 100% model training, it means you haven't got enough data. So either you find more pictures of cats and dogs, which fortunately is trivial, but if that isn't trivial, there's another little trick you can do. It's called data augmentation, and it's actually built right into CreateML. So you can say, I want you to flip the pictures, or rotate them, or change exposure, make them brighter or darker, or shear them to make them look warped on the screen, so that it has to recognize a wider range of pictures of cats and dogs. And it'll do this for you. Now, obviously, I've got like 15 pictures of cats and 15 of dog, whatever. Adding a flip, and adding a rotate, and adding expose, and adding shear, this will take significantly longer for that handful of pictures. So use them if you need them. The other option is to increase the number of iterations. You could try saying 20, for example, go over the pictures more carefully. Be careful with that, because you can actually, one of the problems you might find, if I close that again, if you train your data and get like 100% model accuracy, but not very high testing accuracy, you may have what's called overfitted your model. Your model may have learnt too precisely what your training data looks like. It may have memorized exactly what the pictures look like and not a generalized pattern of what all cats and dogs look like. So you have to reduce the number of iterations at that point. So you can kind of work around things to fix it a little bit. The other thing you might find, if your training accuracy is really high, your testing is lower, just make sure you have the same kinds of pictures in both sets. You know, we have cats and dogs here, but if you said, okay, here's a dog, here's a dog, here's a dog, and then you tested with pictures of 2 dogs, or a pack of dogs, it would have no idea, right? So make sure your testing data matches your training data, at least in the kind of scene you're showing. So that is how you do image classification. I think you'll agree it's ridiculously easy. And of course, the pros do it even better, but to start with, they've made it very, very easy to noodle around with, which is fantastic. You can also use the CreateML system to do text analysis, things like semantic analysis and so forth. How does this mean? What does it feel like? What kind of thing is it? And so forth. And this is only a little bit harder than doing images. You haven't got the sort of fancy pants GUI thing going on, but you can still do it. And it's actually still relatively easy compared to doing it in Python, which is basically true of most things. First, we need some training data. Now, as with image recognition, this means having 80-20, lots of training material, lots of testing material, and so forth. And it's very, very similar. You give it some text to work with. Here is a string, or a paragraph, or a huge document. And here's my label. So it's the equivalent of a JPEG and a directory called cat. So you give it some text and give it a label and so forth. And it's actually all done using JSON, like actually surprisingly trivial JSON. So if I go to Sublime here, I can give you a demo of what it looks like. I'll zoom in slightly because that is really tiny. There we go. A bit chunkier. Okay, so it's an array of stuff, and inside that is going to be a JSON object. Inside that will be some text. And I'm going to do a model very close to my heart, reviews of my awesome books. I'm going to say, so my first text here is going to be hacking with Swift are the best ever books. Can't quite see that, but there you go. Boom, that's my text. And the label for that, what I want to train CreateML to do CoreML with, to understand what that means, that is a positive review. Good thing. Now, again, positive has no meaning to CreateML or CoreML. It's just a text string, but it's saying these letters equal positive. Another one. Let's do another text label. This one is hacking with Swift sucks. I hate Paul Hudson's face. I get some really angry emails sometimes. Really angry. Anyway, I'm going to call that one a negative review. And then we'll do one last one. And this will be a neutral review. So I'm going to say the text is going to be hacking with Swift is okay. And that is a neutral review. Great. So that's the format. That times 11 billion, right? You want lots of data to work with. Now, I am not going to sit here and type thousands of lines of JSON. I said I'd do all the code. That's true. I'm not going to do all the JSON. I'll be here a very, very long time. To get any meaningful data, I'll be here basically the rest of the week. So instead of doing that, I have prepared some data ahead of time. And you'll see it is very, very similar. In fact, identical. So in my material folder, I will pull out reviews.json. And this is a JSON file from an actual machine learning paper written for the Association of Computer Linguistics, ACL, just over a decade ago now. And this uses sentiment analysis using subjectivity summarization based on a technique called minimum cuts, which is from graph theory. That's their stuff. What we care about is I've taken all their data, which is freely available online, and put it into the format that CreateML expects. The same thing, an array of JSON items, text label, text label, text label, and so forth. And these are movie reviews from real people about real films, and they're often very, very angry, and they're not short. It's not like, hacking us just sucks kind of thing. These things are huge, rambling reviews about the finer points of Jaws. That's not even the longest. The longest one's like way over here. It's just vast reviews. Anyway, so these people really like to go on and on about how much they hate films or like films. So, can we throw that at CoreML? Really, really confused, quite frankly, data, and see what it comes out with? Well, yes, we can. We can throw that at CoreML and find out what it looks like. So we've got to write some code here again, not a lot. And this time we're going to use the regular CreateML framework, not the CreateML UI framework. It's a regular CreateML. And the first thing to do is load that JSON into an ML data table, ready, parse the JSON, ready to work with inside machine learning. So I'm going to say, let data equals try ML data table. There we go. This wants a contents of URL initializer. So I'm going to say a URL, and we're going to use file URL with path. And this will be wherever your data is. Now for me, it's going to be /users/2straws, that's me, desktop/material/reviews.json, like that, wherever your stuff is. And that will load the entire thing in, ready to go. But like I said, we've got to have the 80-20 rule. We want some training, some testing thing going on here. Helpfully, the regular CreateML has a built-in method for doing the split for us based on a random seed that's just random of your choosing. So I'm going to use destructuring to say let parens training data, comma, testing data equals data.randomSplitBy. And you tell it a number between 0 and 1, where 1 is give it all the training data and 0 is give it all the testing data. So I'm going to say 0.8. Again, the 80-20 rule. Give 80% to training, 20% to testing. And for seed, it's a number of your choosing. I'll just use 2. That is our data split up, ready to be analyzed. Now we can pass that to a classifier for text by saying let classifier equals ML text classifier. And this has got a number of initializers here. What we want is training data, our training data, and we're going to tell it which column is which. So this text column, that's your text. The label column is your label. So I'm going to say text column is called text, where you'll find the actual ranty reviews, and the label column is just called label, like that. Boom. That's all it takes to have the whole thing load and parse our data, except for the massive typo somewhere in there. Give it a minute. Is it actual typo or is Xcode being rubbish? No, it's Xcode being rubbish. So it's now tokenizing our string. You can see 20%, 40%, 60%. What do you call a fish without any eyes? A fish. Okay, that's finished. Okay, so now it's done, which is great. We can go and use it. But of course, you want to make sure it's actually good. At least vaguely within the parameters you expect to be good. We want to go ahead and test this using the testing data. So we can actually ask it to perform an evaluation on our testing data using its model. So I'll say let evaluation metrics equals classifier dot evaluation on. And we're going to pass it our testing data. Look at this data, figure out how good or bad it is. And it will report back to us the classification errors. So we can write back here next, let error rate equals evaluation metrics dot classification error. How many mistakes were found? How many were wrong? That'll come back as, again, 0 and 1, where 1 is complete failure, 0 is completely perfect. So we're going to multiply it by 100 to get something more human readable. And then I press play. And there we go. The number comes back is 11%, which means 89% of the time, based on that data, it will correctly get sentiment analysis on that text. Which I think is remarkable given how little work we've done. You can customize this further. There are other ways of analyzing the data if you want to. If you didn't find out, you want it even more accurate, you can delve in more if you want to. Depends on your data. So that now shows we have successfully got a text sentiment analysis, which is fantastic. We can go ahead and save that somewhere as a core ML model for us to go and use. So you first attach the metadata, who made the thing, what license it is, what description it is. These all appear in Xcode later on. So I'll make an ML model metadata object. The author is me. Description is movie reviews. Analysis, it's fine. Analysis, there we go. And the license is some comedy license. Let's do CC0. And the version is 1.0, and whatever. Additional isn't actually required. So there we go. So that basically wraps our model in some data so folks know how they can use it. And finally, we'll do try classifier.write to some URL. Again, it's another URL, so we'll just do URL file URL with path, and I'll do users, two straws, desktop, reviews.ml model. Boom, and press play. There we go, it is saved, and there it is. There's our ML model. It's a bit slightly larger, I expect. There we are, it's 900 kilobytes. And that's approximately 8 megabytes of JSON. We can now throw more things at it and get 89% accuracy, which again is Core ML doing most of the work, Create ML doing most of the work, but it does still leave one problem that Apple can't really solve, which is that most of the time finding data sets is actually quite hard, particularly if it's your own custom stuff. You've got to go and get the data somehow. That's not trivial. If you want to, you can go ahead and look for awesome public data sets, literally awesome public data sets on Google. You'll find a GitHub repo full of stuff you can just grab and use and reuse. It's research people. They love letting people reuse their stuff. Check it out. And that is Create ML without any problems. Let's have a look at the next topic. It should be hopefully easier. This is how you use a new iOS 12 alert grouping thing to make your app less bothersome. Now, Apple made a big push about this at their keynote, about how they want to help ease us folks off their computers and iPhones and notifications all the time. Just a little bit less. So they've got more aggressive do not disturb, for example. They have this grouping of threading of notifications and so forth. And this is one of the part of the solution. And what it means is one app, rather than showing 10, 20 notifications at the same time, can coalesce them together in one place and just show one notification, which is much, much nicer. Even though this change might seem really small, it's one of those things that if your app is not grouping things well, and other apps are, it'll kind of stick out like a sore thumb. So you might want to adopt these if you're showing notifications currently. So I'm going to go ahead and create a basic app. Again, there's no magic here. I'm going to try and do as much as I can live. So a single view app's fine. I'll call this one notifications, and then desktop. So if you've used the iOS 10 user notification framework before, you know it's not too hard. You import user notifications here. And you start by asking for permission to show notifications, of course, because otherwise it's too annoying. So we're going to say UN user notification center dot current dot request authorization. There we go. The options are what kind of things you want to show. So we'll go the full hog and say we want to show, alerts and badges and sounds. Let's really go the whole hog. And then a completion handler. When this thing has been approved by your user, what do you want to do? And for now, we're going to have to take the 2 parameters in. Did it work or not? Did it fail? So we'll say granted error in. And if it's granted, we're just going to do yay, else print do. Like that. Okay. While that's thinking, I'm going to press not input view, in, you silly thing. There we go. Great. So the next step is to schedule a notification, something to show on the screen. So we'll make a method for that. We'll call this one func schedule notification. Schedule notification. That. There are 3 parts to this. You first create your content. What do you want to show on the screen? So I'll say let content equals a UN mutable notification content. I'll say content.title equals title equals a late wake up call. That's the thing at the top bar. Then some body. I'll do content.body equals the early bird catches the worm, but the second mouse gets the cheese. You can attach some context if you want to. You could say, content.userinfo equals message style is important, whatever you want to. Boom. And then a sound. And we'll do UN notification sound dot default. There we go. Brilliant. That is our content. Now, when to show it, you could say at this exact day and time. You could say at 10 seconds. You could say, when I leave this location. I'm going to say a number of seconds. So I'll do let trigger equals a UN time interval notification trigger. This has a time interval. I'll do 4 seconds. Repeats false. And the third part is to tile that together into one request. So we'll do let request equals a UN notification request. There we go. This has an identifier, a unique string identifying it, so you can delete it later on if you want to. We don't care, so we'll just do a UUID.UUID string, a random string basically. Our content is our content thing, and our trigger is our trigger thing. So that's our notification. And finally, we can add that to the system by saying UN user notification center dot current dot add that request. Boom. Okay. Whew. That is the magic-free version of doing iOS 10 notifications. But that's all old stuff, right? It's pretty boring. I'm going to obviously call this method up here, so it actually does something useful. Boom. That needs to be self-dot because we're in a closure. Great. And I'll press run. That will build and launch the simulator, which gives me ample time to tell you some more bad dad jokes. What's orange and sounds like a parrot? A carrot. All right. So now it's built and run correctly. I'm going to go ahead and run this. Now it's all working. I'll run it again and hopefully show a notification. Let's find out. There we go. If I zoom in there, you will see there's our message and our title looking good. That's how it looks right now. I'm going to go ahead and imagine we've got a busy, overactive friend texting us again and again and again and saying things. I'm going to repeat this thing multiple times. I'll say for I in 1 through 10. Do that. Give me the same message 10 times. And now see what happens. There we go. That's it complaining. You can see now our message is there. It's stacked neatly. It says 9 more notifications below it. This has kind of worked. That's not bad. I've literally done nothing at all. Just repeat the message again and again. It kind of works. But it's assuming that all these things belong to the same thread. So all your friends texting you about the amazing WWDC announcements that didn't happen would appear in the same thread, rather than having multiple threads based on, the friend's name and so forth. So you kind of get something for free, better than nothing, but it's not ideal. You want to split up into different threads. And that's where 2 new properties come in on your notification. The first one is a thread identifier. This is an internal string for iOS to look at and understand this belongs to that thread, this belongs to this other thread. Do whatever you like, it's just a string to identify it uniquely to iOS. The second thing is called a summary argument, which lets you add some more text here where it says 9 more notifications. You might say 9 more notifications from your husband, or notifications from your hamster, whatever it is, right? You can add it in there to customize the UI and make it more useful. So, inside our little loop here, we're going to simulate that with a bit of modulus. We're going to say if I%2 is 0, so if it's an even number, we'll do content.threadIdentifier equals Andrew, my brother. I'll do content.summaryArgument equals your brother. And then in the else block, I'll say, well, first I'll copy and paste because I'm quite lazy. I am typing standing up, which is really hideous, actually. Identifier will be Sophie. So I'll say your daughter. There we go. And now I press Command R. There'll be 2 threads all being well. Good sound. There we go. So you'll see 4 more from your brother, 4 more from your daughter. So you get the proper integration you should have had all along, and it's not so hard. Now there is one more thing. There's one more thing I can't actually show you because Apple literally won't let you have it. Won't let me have it. Top secret right now. It is a new option for requesting permissions, alert badge, and sound you've seen. There's a new one in here, which is called critical alert. This is because the new do not disturb stuff really does lock down your phone. It hides all notifications, it kills all sound and so forth. A select few apps will be granted special dispensation from Apple. Literally, you have to ask permission to use this, to override do not disturb. Obviously, Clash of Clans will not be in there and similar things like that, right? Most of the apps I certainly create will not be in there, but a handful, like emergency services and so forth, will be able to request to override do not disturb, get out of bed. And there's actually a new sound you can play, or we can't play it, which is the critical alert sound, default critical. There's an earthquake coming, get out of bed or something, right? That's something that really matters. I really doubt they'll give out permission easily. You can try and ask, they hear it, WC, why not? But probably not. And that is the new threading. It's not too hard, I think. Okay. Still no serious problems, I think, either. I think we're doing pretty well. Let's head back to the playground. There's a new framework called natural language. Natural language. And this, in iOS 11, Apple introduced a improved version of a foundation class called NS Linguistic Tagger. It was kind of cool before. iOS 11 really took it miles forward because it added all this ML behind it to do things like text analysis. What's the language in the string and so forth. And it worked. But in iOS 12, they've kind of rewritten that. The API is very, very similar. The code's underneath. But they've rewritten it under this gorgeous new Swift API that makes it significantly easier for us folks to use. And it does all the same sorts of things, a couple more perhaps, but in this lovely new API, it makes it really, really easy to use. So we can put it to work straight away. We can ask it to recognize languages inside text. It's already been trained to recognize lots and lots and lots of languages. So we can say a string. I'll do a multi-line string because I'm all Swift for and all that. I'll do thrusts his fists against the posts. Oops. And still insists he sees the ghosts. There we go. Stephen King's It. Terrifying. Anyway, we can now ask the natural language framework to tell us what language that is. Now, we know what it is. It's French. It's English, right? But we can ask it to recognize it for us. We can say if let lang equals NL language recognizer dot dominant, come on, dot, there we are, dominant language for string. And pass it our string, boom. And then we can say, okay, we now know the language, what was it? If lang equals equals, and you can see the language that it recognizes in text. There are quite a few of these. So you just whisk them more, find what matters to you. I'm going to do English, and I'll do print, it's English. Else, print, it's something else. There we go. And play that. Boom, it's English. You can see it's printed over here. Now I should say, it's called dominant language for a reason. it can actually, given multiple languages in the same string, figure out which one is the prominent one. So you can give it a lot of text and it will work through it very quickly. But as you also see, it can return nil. It may have no idea what language it's working with, so watch out for that. I should say, if you give it very, very small amounts of text, like the word table, is that table, English, or table, French? It can't tell. A human couldn't tell, right? You've got to have more context. You don't give it very, very short strings. However, you can feel very free to give it long strings. This thing will work through thousands of article-length strings per second. It's blazing fast. You can give it an entire Twitter feed and say, which ones are in my language, and just filter that in a split second. It's remarkable. You can also have this framework do other things, but we're running out of time, so I might skip forward. Skip forward. Yeah, fine. Natural language. Language, boring. Well, I've got 4 minutes left, and I'm going as fast as I can. Let's go back to our little Xcode project, and we'll look at shortcuts, because this is brilliant. This is where you can kind of hook in your app stuff right into Siri, right, which is really neat. This is a big upgrade from iOS 10. SiriKit, by the way, if you use that, you can get a ride share, you can send money, you can do messaging, and not a great deal else. Now, you can pretty much hook in whatever you want based on how they record their voice. Now, cunningly, I can do all the code for it, but the actual runtime will not work in the simulator. You have to use an actual device for that, but I can at least walk you through how it works, because it's remarkably simple. All right, let's get rid of a lot of junk. Apple's given us 2 APIs to use. One is extremely easy, and one's extremely hard. You can guess which one I'll demo today. But honestly, I really expect folks will use the easy one to start with, because for all you know, your users might not care. Don't invest lots of time and money and hassle in figuring it out and stuff if no one cares. Put the easy one out, get feedback, gauge feedback. If they like it, they want more, fine, roll out more. Start in baby steps. Helpfully, the easy one's all done using NS user activity, which you've probably met already with things like Spotlight, indexing, handoff, SiriKit, and more. This is a multi-talented class, and it comes back again to do Siri predictions and so forth. And you can make as many of these as you want, attach them to any view controllers you want, and it will understand that thing means some behavior. For example, your detailed view controller might be a restaurant nearby. You can say, okay, here's my activity, this restaurant, this address, yada, 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 attached to my view controller. And that way, when it's shown by iOS, it will automatically understand this activity means this view controller. It's really, really cool. Anyway, first things first, we have to tell iOS what activities we support. At a global level, what do we support? You go to your app list, choose Add Row, and zoom in because it doesn't do font sizing very well, this thing. And you want to add a thing in here called NS User Activity Types. Boom. Make it an array, then bring it out and add exactly one item, which is a reverse domain name format of a unique ID for your thing. It's like a bundle ID, right? So I'm going to use com.hackingwithswift .example.showScores. Show the score somehow. And I might just copy that to my clipboard. There we are. Okay. And now in the view controller, assuming it's going to load and do stuff, yada, 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 finally, when this thing did appear, when it's actually all configured correctly, we know it's in there and so forth, at this point, we're going to create an activity. We're going to say, let activity equals NS user activity with the type string, which is going to be that long thing. And we're going to say, give it a title, which will be show the latest scores. Activity, you have to allow this thing to be searched for by Siri and by Spotlight inside the system. So you enable is eligible for search equals true. Then activity dot, the important new one, is eligible for prediction. Eligible for prediction, there we go. Which means Siri will watch when this activity is shown, i.e. in your view controller, try and figure out what time of day it was and similar things, and present that to users later on. You can add some context if you want to, with another user info dictionary. So you might say, restaurant was, if you haven't been there yet, this is place just downtown, Peggy Sue's, not brought to you by that brand. And finally, you'll have a persistent identifier, so you can delete it later on if you want to. So we'll do activity.persistent identifier, equals our new NS user activity persistent identifier. There we go, with the raw value of ABC. If you want to delete it later on. And finally, self.activity, user activity, sorry, equals activity. Attach activity to our view controller. And that is what's calling donating the activity. With that setup, Siri will now ingest that as soon as the user lands on there, and it will start appearing in their suggestions straight away. You have to write some code to have it triggered when they launch the thing, but that's pretty trivial because in the app delegate, it has a new method in here. It is called, it's a long one, it's user activity. I can't even see what these things are because the screen resolution is so slow. That one? That one, yeah. Continue user activity restoration handler. And you'll give the activity back to you. You can say, you know, if user activity dot activity type equals my string, then, you know, do stuff, whatever. And then finally return true, say you've handled it successfully. And that's all our code done. Now, I can't actually show it here annoyingly because it doesn't work in Simulator, but I can show you two really important settings. Make that bigger, get bigger. There we go. In Settings app here, scroll down for the developer window, and at the very bottom of that, you will see display recent shortcuts and display donations on lock screen, which means you can just swipe down from the home screen to see what's been registered recently. Little hacks, you can see what's happening, otherwise it'll be all invisible. This shows you at a glance what they are. You can tap on them, trigger them, make sure they all work correctly, which is really, really nice. I'm actually out of time, but I couldn't end this without saying iOS 12 deprecates UI WebView. After 11 years of hard service, good night, sweet prince. Thank you. I'll be around after if you have questions. Come and grab me.